Hello guys, welcome again to this video. In this video we will be studying about gamma distribution, and as you can recall from the last videos that we have studied about different kind of distributions of discrete distributions, and we have recently started about continuous random variables. These are all the different kinds of distributions that we are going to study. So for today's topic it will be gamma distribution, and we'll be covering the entirety of gamma distribution with some solved examples with like the PDF, the CDF, the expectation, the higher moments, and everything else that comes along with it, right? But first we need to understand what is a gamma function. So basically, where does this distribution come from? So this is gamma distribution. Now for the gamma distribution, as I had said, we need the gamma function. So first we need to understand the gamma function. So first we shall see the gamma distribution and gamma function. So the gamma function is denoted by, I'll write you the letter for it. Denoted by gamma is like this of n, where n cannot be a negative natural number, right? That's what I mean. Obviously it cannot be 0 as well. So gamma of n. So first let us define it for natural numbers. Let us define it for natural numbers. So the gamma function is such a function that it can be used in case of natural numbers, in case of real numbers, and more so in case of complex numbers as well. So obviously what I'm going to give you is firstly an universal representation of how to use the gamma function. So it is as follows. So for n belongs to natural numbers, that is n is like 1, 2, 3 and so on, that is all the positive integers, we can divide gamma of n as integral from 0 to positive infinity x to the power n minus 1 multiplied by e to the power minus x dx. So this representation is basically that of the gamma function. Now since I said we will first try to find the value of it for natural numbers, and when I say the value of it, it is a very explicit term, because as you can see we already have an integral representation and this should be enough, right? By value what we generally understand is some way of calculating it which is easier than others, which is more well known. Okay, so for example, if you had gamma of n equals to some n by 2, you would say that is an easier form that than the integral is, because in that I'm just taking the n and dividing it by 2, whereas doing the integral would take a lot more time. So when I say a simpler form, what I mean is that we are using simple elementary functions and we are not trying to use it a derivative or integral if it's possible, only then. So for this it is possible to do that. It is possible to express it without the help of any infinite series or integrals or derivatives. But how do we achieve that? Let us see. So we are going to use integration by parts. So gamma of n equals to 0 to positive infinity x to the power n minus 1 e to the power minus x dx. And you remember from our Eilert rule that algebraic functions, that is the one that stands for a, comes first, and then at the end comes e, which stands for exponential functions, right? So this would be function 1 and this would be function 2. Now since we do know the procedure for integration by parts, we can apply the following: x to the power n minus 1 multiplied by e to the power minus x dx integral, and this evaluated from 0 to infinity. This is because we are directly doing the IBP on a definite integral rather than an indefinite integral. So we do the same thing, but at the end we evaluate it from the lower and upper limits. Minus integral of 0 to infinity derivative of x to the power n minus 1 multiplied by e to the power minus x dx, and you can have another dx here because it will be used for the outer integration. So like this is basically the format. Now what we hope to achieve by this is something as follows. Firstly, this integral would mean minus e to the power minus x to the power n minus 1 0 to infinity minus, and this integral of e to the power minus x would produce a minus, which would combine with this minus and it would become a plus. So it becomes 0 to infinity. The derivative of x to the power n minus 1 is just n minus 1 into x to the power n minus 2, and it is e to the power minus x dx, right? Now we need to understand what this limit stands for, right? So let us do it here. So let us just put the 0 part first. So first let us have limit x tends to infinity. This would be minus x to the power n minus 1 by e to the power x, and when you have the 0 part, it already becomes a 0, so it's just a plus 0. So what you really have is minus limit x tends to positive infinity, of course, x to the power n minus 1 by e to the power x, and we hope to find this limit. Now observe that e to the power x is simply equal to 1 plus x square by 2 factorial plus x cube by 3 factorial. And if you wish to include the n minus 1th term, which is x to the power n minus 1 by n minus 1 factorial plus x to the power n by nth factorial, and so on, right? Because this is basically the Taylor series expansion of exponential of x. Now if we can use this expansion in a way where we can put the value directly like this, where we have limit x tends to positive infinity, x to the power n minus 1 divided by, now we have this part here where we have x to the power n minus 1 by n minus 1 factorial plus x to the power n by n factorial and so on, right? So dividing up and down by x to the power n minus 1 should give us 1 divided by, so this would become 1 by x to the power n minus 1, this would become 1 by x to the power n minus 2, and this term would become 1 by n minus 1 factorial, but this would become x by n factorial. The next term would have been x to the power n plus 1 by n plus 1 whole factorial, which would rather become x square by n plus 1 whole factorial and so on, right? Now if you apply the limit individually to all the terms, what you do get is this 1 by, so this term would be 1 by positive infinity, which is 0, again a 0, and all the way up to 1 by n minus 1 factorial, which is just a constant. But then you have the terms of x, right? Then you have the terms of x square and so on. So this terms will give you a positive infinity, and all of them added will give you a positive infinity, and 1 by infinity is just 0. So that limit L here is basically 0. So coming back to our function, so coming back, we see that gamma of n is equals to 0 plus n minus 1 into 0 to positive infinity x to the power n minus 2 into e to the power minus x dx, and this would give you n minus 1 into gamma of n minus 1. This is the recursive definition. In the next video we shall try to find out how this recursive definition can be used to make the value of gamma function in terms of just n, and from the next chapter onwards we would try to see all the different properties that are present with it. There are a lot of things going on with the gamma function, and once we are clear with the gamma function, we can understand how to do problems on gamma distribution and even so beta distribution as well. Thank you for watching. So please download the Breatter Maths app, which is given in the description. It is a mathematical app where you can find all the necessary statistical calculators like chi-square calculator, one variable means, population means, t-value, and much more. You can also find calculus related calculators like integration, derivatives. There is a section where you can find what's coming up next. There is a section completely devoted on mathematical notes where you can find notes on probability, statistics, calculus, and many more are there to come. In those notes we have already explained all the examples, all the problems and theory, and we are just covering the video lessons and solutions of those here. You can check that out. Also you can see the video solutions in a separate section where you can understand and give a feedback on what to expect next. You can ask for a problem, you can ask for a theory section as well. So please do check it out, and also do subscribe to Breatter Maths app and also its YouTube channel.